The journey of crude oil to petrol, from raw reservoirs to fueling cars. Have you ever thought about the science behind what fuels your car? The transformation of crude oil into petrol, commonly known as gasoline, is a remarkable journey that combines innovative engineering and chemistry. This process not only powers our daily lives, but also connects us to highly complex industrial systems. In this video, we'll look at the entire process in detail, breaking it down step by step. By the time you finish, you'll have gained a deeper appreciation for the fuel in your car and the science that makes it all possible. The story of petrol starts deep underground with crude oil, a naturally occurring unrefined fossil fuel. Extracting crude oil requires precision and equipment capable of reaching reservoirs buried miles beneath the Earth's surface. Using sophisticated drilling machines, oil companies extract crude oil through wells drilled into rock formations. Once the drilling process completes, the crude oil is brought to the surface. It's a mix of hydrocarbons and impurities like water, sulfur, and minerals. At this point, it's far from ready to fuel our cars and requires extensive refinement to ensure safety and efficiency. This begins the crude oil's journey to refineries. After the crude oil is extracted, it needs to travel great distances to refineries where it can be processed. Massive pipelines, enormous oil tankers traveling by sea, and rail systems are the key transportation methods. These systems are designed to safely and efficiently move millions of gallons of oil across countries and even continents. However, safety is critical during transit. Oil spills or leaks can be costly and environmentally damaging, which is why strong protocols and technologies are in place to protect both the cargo and the environment throughout this transportation phase. Before crude oil can go through the distillation process, it first undergoes desalting. This crucial step involves removing impurities like water, salts, and sediments. Why is this necessary? These impurities can corrode refinery equipment and reduce the efficiency of the overall process. In desalting, the crude oil is mixed with water and passed through an electrical field. This causes contaminants to separate from the crude oil, allowing them to be removed. This is the first major purification step, making crude oil ready for further refinement. Once desalted, the crude oil enters the centerpiece of the refining process, fractional distillation. This is where the magic of chemistry plays a key role. Crude oil is a mixture of hydrocarbons with varying boiling points. Fractional distillation takes advantage of these differences to separate the components. First, the crude oil is heated in a furnace to temperatures of around 400 degrees Celsius, 750 degrees Fahrenheit, turning it into a vapor. This vapor rises through a tall distillation column where it cools gradually. As it cools, different hydrocarbons condense at various levels within the column. Lighter products like gasoline condense near the top, while heavier products like diesel condense further down. The distillation process produces several essential components including gasoline used for cars, kerosene used for jet fuel, diesel used for heavy vehicles, other byproducts such as lubricating oils and asphalt. Each of these components has unique properties and applications. However, gasoline in particular needs further refinement to meet modern engine standards and environmental regulations. Here's where gasoline gets its signature performance upgrade. During the reforming process, the hydrocarbon structure of gasoline is modified to improve efficiency and produce a higher octane fuel. A higher octane rating means the fuel burns more smoothly in modern engines, reducing knocking and improving performance. Blending comes next. Refineries mix the processed gasoline with additives to meet environmental standards and increase engine compatibility. Additives can enhance fuel efficiency, lower emissions, and create cleaner combustion. Ever noticed terms like unleaded or premium in fuel stations? These are indicators of the gasoline's composition determined at this very stage. Before gasoline ever reaches a fuel station, it goes through stringent quality control tests. These tests verify its properties, ensure it meets emissions standards, and confirm that it's safe to use. Testing involves measuring octane levels, examining chemical stability, and ensuring precise blending of additives. This focus on quality safeguards not only modern vehicles, but also the environment by minimizing harmful emissions. After refinement, the Petrol is ready for its journey to fuel stations. Using specialized tanker trucks, pipelines, and rail systems, gasoline is transported in bulk to distribution centers and eventually to stations. When you fill your car at the pump, you're at the final stop of a highly intricate supply chain. This seamless distribution system is a testament to the collaboration between science and logistics, ensuring that we never have to think twice about whether petrol will be available when we need it. The transformation from crude oil to petrol would be impossible without cutting-edge technology. Refineries rely on advanced equipment, automation, and computational models to optimize every stage of the process. For example, engineers use real-time data to adjust the refining process, ensuring maximum efficiency and minimal waste. This technological precision not only improves productivity, but also reduces environmental impacts like carbon emissions. As efficient as the oil refining process is, it does come with environmental concerns. Air pollution, greenhouse gas emissions, and the risk of oil spills are critical challenges. Refineries are investing in cleaner technologies to reduce their carbon footprint, such as capturing emissions, improving energy efficiency, and transitioning to renewable sources where possible. Moreover, the conversation around biofuels and electric vehicles plays a significant role in shaping the future of fuel dependency. While petrol remains a staple for now, alternative energy sources are being developed to provide more sustainable options. Petrol powers more than just vehicles. It drives economies. From industries to transportation systems, its availability impacts global trade, energy markets, and even geopolitical stability. However, the environmental cost highlights the importance of balancing its benefits with sustainability efforts. Here's a fascinating fact for you. The world refines about 100 million barrels of crude oil per day. That's enough to fill nearly 4,200 Olympic-sized swimming pools every single day. This scale highlights how essential oil refining is to modern life. In summary, what began as crude oil deep underground completes its journey to our fuel tanks through a meticulously designed refining process. From extraction and desalting to distillation, reforming and distribution, every step employs the brilliance of chemistry, engineering, and logistics. Understanding this process reminds us of the science behind everyday conveniences. The petrol you pump into your car is the result of extraordinary efforts by scientists, engineers, and operators working together on a massive scale. The next time you fuel your car, remember the incredible journey that brought petrol to the pump. It's a story of innovation, precision, and a deeply interconnected world. What fuels your curiosity about how things work? Share your thoughts below and join us for more explorations into the science behind everyday life. Thank you for joining us on this educational adventure. If this video sparked your imagination, don't forget to like, share, and subscribe to keep uncovering the wonders of science.